Hi, my name is Eric McKevitt, and today I'll be presenting my computer vision final project, traffic violation detection. So, a brief introduction. This project will entail detecting red light violations at intersections. So, you may ask why I would be interested in this project. Well, as it turns out, 260,000 red light crashes occur annually, and of these, 750 result in fatality. So this is obviously a very high number, and this is a terrible statistic, but it would be a noble effort to reduce this number in any way. And so you can imagine that if there's a system in place that is able to reliably detect red light violations, there's a chance that this would discourage any red light violations from occurring. And so this number might be lower. So this would be the motivation for doing a project like this. And so detecting a red light violation with a computer vision technique would be the goal for this project. And speaking of, let's define the technical goals. So these would be to accurately detect the vehicles running red lights. And in doing so, we want to minimize the number of false positives. We also want the system to be able to generalize to both day and nighttime conditions. So as the lighting conditions change, the accuracy of detections should not change. They should always be high. So that will be a goal for this project. And now let's outline some of the previous work in this space. Generally speaking, there's two types of solutions that people go for. The first one, which is the most familiar, is sensor-equipped systems. And this is the conventional two plates in the ground that measure the speed of a vehicle as it crosses them. And from this, it's able to deduce the speed of the vehicle. And if the speed is high while the light is red, then it knows that the vehicle was passing a red light at a high speed, thereby committing a violation. And in this case, it will take two photos, one from the front and one from the back, and then use optical character recognition to use or to scrape the license plate number. So this is a bit of a flawed solution in some sense because this is actually quite expensive to install these sensors. And then the other issue that this has is as soon as you have bad weather, especially here in Colorado, you have a lot less accuracy with these predictions as far as the speed that the vehicle's traveling at. And in some cases, the system can fail altogether. So if you have the cameras in place to take the two photos from front and back, why not use them to their full potential and implement a computer vision solution? So some have done that, one vendor being Flow by Data from Sky. And the software they offer allows you to detect red light violations, as I'll be attempting to do. And it also offers other various features, such as counting the number of cars in some space and detecting the number of free and taken parking spaces. So you can see the user experience here. The user just draws a bounding box around some traffic light, and it's able to detect the state and monitor that over time. They don't go into the specifics of the techniques that they use for vehicle detection and tracking and all that. This is a commercial software, so I wouldn't expect them to. But a lot of companies have done this and commercialized it, so it is a very popular technology. So, technical approach that I'll be using is as follows. I kind of have it divided into three pillars or three big pieces that I wanted to tackle. So the first is object tracking for vehicles. So for this, I'm going to use Yellow V5 and Sort. So Yellow V5 out of the box is just an object detection model. It has no knowledge or conception of tracking. So where that comes into play is with the sort algorithm. So using this algorithm and Yellow V5, we're able to achieve something to the effect of tracking vehicles from frame to frame. And each vehicle is labeled with an ID so that when it commits some kind of violation, we're able to flag it as such with a label. So the second piece of this is red light detection. And for this, we have to both detect a stoplight and detect if it is red versus yellow or green. So the first half of that, detecting the stoplight, I use template matching, which of course involves filtering and thresholding, but I also use dilation to enhance the template image beforehand. And then as far as telling whether it's a red image, I use color masking to achieve this. And then to improve the performance of this pipeline, I've been using morphological opening to remove noise. Finally, the third piece of this is having a line that the vehicles need to cross while the light is red in order to have a violation occur. And so for this, I just have the user select 2 points at the beginning of the program, and then using that line, it's pretty simple line equations to detect whether a vehicle sensor has crossed between 2 frames from one side to the next of that line while the light is red. And the one nuance with this is that the vehicle has to cross from the bottom side of the line to the top side. And this is because vehicles in the opposing lane, if this wasn't a constraint that we imposed, they would always be having violations assigned to them. And so this is obviously something that we need to catch. And so vehicles must go from the bottom side to the top side of the line to have a violation occur. So now let's talk about the experiment that I conducted. So I sourced videos of red light violations from public YouTube videos, and I made sure that these would span both day and nighttime settings. And the goal here was to run these through my program and check to see if each of the violations were caught by my system. And also importantly, to detect if all of the false positives, like if we could minimize the number of false positives. So these two goals in mind, let's go ahead and check out the demo. So here's the nighttime demo. You can see as the vehicle passes over the line, its bounding box will be colored differently, and that will be logged as a violation. You can also see the bounding boxes on the stoplights changing color as the light goes from yellow to red. And then in the daytime demo, you can see a similar situation. This car will run this light and its bounding box will change colors. There's a few false detections in both cases, but overall the system seems to be functioning as expected. Okay, and so now that we've seen the demo, let's go ahead and discuss some of the limitations of this system. So the first one is that if any red light is present in the image, the system will listen for incidents, meaning it has no lane specificity. And this is obviously a big issue. So if one lane has a red light, but the other ones are free to go, those lanes that are free to go shouldn't be flagged as having a violation. This is obviously a big flaw, but solving it would require most likely a machine learning solution and would be out of the scope of this class. The second limitation would be that the user has to specify the line to cross. So this is just a user experience limitation. The functionality of the program is not affected in any way, but it would be nice if this could be selected automatically so that you could deploy this system to any new environment at any scale and counts on it working without any human intervention. So this is a limitation. So now let's talk about future work. And a lot of this would be addressing those limitations. So again, using machine learning to pair all of the lights with each of the lanes. This would be a huge improvement to the accuracy of the detections, and it would also minimize all of the false positives. Secondly, we would want to use template matching to identify the line instead of having the user select it. My suggestion here, my suspicion, would be that you could use the crosswalk. I wasn't able to achieve any good results with this in my limited testing, but I would imagine you could do template matching on the crosswalk and then offset it vertically from that point so that you don't have false detections. And then finally, the last piece of future work would be to extend this project beyond red light detection. So this would be something like identifying speeding or any other traffic violations. the fact that we have yellow E5 and sort working together to have vehicle tracking as well as stoplight detection and sorting them by their light colors. This provides a good baseline for any future projects in this space. So it would be interesting to see what could be done. And so, yeah, that about sums it up. So I hope you enjoyed this presentation and thank you very much.